This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello, this is Diomidis Spinellis for Software Engineering Radio. Today I have with me Marc Hoffmann, and I will be talking with him on code coverage analysis and the JaCoCo tool. Marc Hoffmann is considered the leading expert in bytecode coverage analysis. Marc wrote Eclema, a free Java code coverage tool for Eclipse, which won the Best Open Source Eclipse-based Developer Tool Community Award in 2008. Later, Marc started the JaCoCo project as a modern code coverage backend for Eclema and other tools, which is now widely used as a code coverage engine, including for OpenJDK development. For his contributions to the community, Marc was recognized as a Java champion in 2014. Marc, welcome to Software Engineering Radio.
Hello, Diomidis. Thank you for having me here today.
What is code coverage analysis?
Well, it's a dynamic metric, so you execute a piece of code or your application under test and record the pieces of code which has been executed, like which line of code, which branches has been taken, which instructions. So you get a detailed metric, so what has been executed. You typically use that for automated tests, so typically for unit tests. You have a unit test suite, and the coverage analysis tells you something about the quality of your unit tests, especially the completeness. So what parts of your code base has been executed by your test suite.
And why is this useful to know?
Well, this gives you a good idea, especially about the untested parts of your code base. So you can identify the places which need more testing, where you should write more tests and have a look at them. Maybe there's a chance to also delete code. So if maybe the code is not required at all. So it helps you to keep your code base clean and tested.
In projects, how do projects typically use code coverage and test coverage analysis?
First of all, you need to somehow integrate it into your tool chain. So the simplest way is that you have the code coverage tool directly running in your IDE. So most IDEs like Eclipse support code coverage out of the box today. Eclipse, for example, is now backed with the Eclema plugin, our first plugin, which is now part of the Eclipse platform. This is the simplest way to get started. But then you should really thinking about making it part of your continuous integration pipeline. So make it part of, for example, your Maven build and integrate it here. Also Gradle, all of the build systems have integrations for code coverage nowadays. So you can continuously monitor the code coverage. And you might also put a tool on top of it, for example, SonarQube, to get like a time series how your code base evolves in respect to various metrics. One of them might be code coverage.
So often in continuous integration, you have something that fails the continuous integration. Do you have a specific limit regarding code coverage? Do you have a metric and a value that you use for that purpose?
Actually, I get this question quite a lot. So what is the good percentage or whatever? The issue here is that the fact that a particular piece of code has been covered only means it has been executed. There's no meaning about the quality and the value of the test. For example, think about unit tests which simply invoke code, but they do not have any assertions. And this is what you really want to avoid in your project. So my typical advice is to keep an eye on the untested code. So where do you have areas of untested code in your code base, and think about how you can add valuable tests to this untested code. Or maybe think about just deleting this code. Maybe it's not necessary anymore. So what I recommend teams typically is not care about percentage, but care about the total amount of untested code. And over the course of the time, make sure that the amount of untested code, the absolute amount of untested code, does not increase.
Thus, the developer should look at the code that has not been tested in a qualitative manner and see what type of code it is and whether additional tests are needed. That's your advice?
Absolutely, and keep an eye on the untested code. So don't rely on the fact that you have like 80 or 90% code coverage, because the unit test could be useless. And especially if you have if you create a competition between teams, and if you make it a management metrics, there's always the possibility that developers start writing useless unit tests just for the sake of the metrics. So this is local optimization. This doesn't make sense.
It happens with many metrics. And can a tool allow you to see such things, such gaming, or is it just a result of bad management focus and there's nothing that can be done about it?
No. The tool, or the pure code coverage tool, cannot tell you about that. There are other tools like mutation testing. Mutation testing actually checks whether the unit test checks the behavior of your code. So in mutation testing, which is quite an expensive metric, you modify the code under test. For example, you change boundary checks in the production code on the fly, and the tool verifies that the corresponding test will fail. So if you can, for example, replace a less than operator with a greater than operator, and there's no test failing, this means that your test suite is probably not complete, or there's no proper validation in
it's not exercising that code as it should be. It's not properly testing it.
Maybe it's exercising, but it doesn't care about the result, because you completely inverted the meaning of the condition and nobody was noticing it. So that's a more valuable a metric, but it's depending on how you exercise. It's a very expensive metric and takes a long time to actually execute and build such metrics.
And continuing on metrics, I have two questions. First of all, there are also multiple understand metrics for code coverage, such as function, statement, branches, conditions, and so on. Are there particular things we should be aiming for those metrics, or in general you're looking at just code and untested code? Okay,
there's it depends a bit on your use case. So obviously what it's very easy to understand is like line coverage. So you can think of lines of source code, and everybody can think about this, and this is like a very simple metric. But there are more advanced metrics. I really recommend to have a look at, for example, cyclomatic complexity. This is an old formal definition which basically gives you an idea about the number of independent test cases you need to test a specific method. So if a method has a cyclomatic complexity of 5, you need at least 5 independent test cases to make sure all branches and all paths within the methods are executed. This is quite interesting. So we integrated this in JaCoCo and provide a metric which is called like missed complexity, covered complexity, or missed complexity. So if our method given from the example with complexity 5 has a missed complexity of 2, this means there are 2 unit tests missing. And this is quite interesting. If you have like a large project and you see like, okay, to get full coverage, the missed complexity is around, let's say, 500. This means it would cost you to write 500 unit tests to get full coverage on this project.
So you know the amount of work that is required.
Right.
And full coverage is something that we should be aiming for, not as a metric, but as a goal. Is that right?
No. Actually, the approach is it depends on the approach. So if you have it, it's nice. But just to do it for the sake of coverage, this typically leads to completely useless unit tests. This is what I was talking before. But if the process is that you work in a complete test-driven way, and you always work test first. So whenever you fix a bug, you write the reproducer first, which is a unit test. If you implement a new feature, a new component, you always write the test first. This is definitely the best process you can follow, and this is what I always recommend to do this, because beside code coverage, you get other benefits in respect of in terms of quality for your code base. If you write unit tests first, think of the unit test as the first client of your API. So if you design an API of a component, the unit test is the first verification whether the API is usable and whether the API makes actually sense.
And if you follow that process, you will arrive at full test coverage, but as a result of the process, not as an explicit goal, right?
Absolutely. This is, and you get more value than just code coverage. Code coverage as such is no value to your project.
I think this is something our listeners will appreciate as an insight. Can you give other some examples from industries or projects that achieve high coverage or where a high coverage is required?
Of course, there's like in industry, like railroad, which deal with safety components or safety relevant software components, or in airplanes. There's also specifications which require a certain or full coverage or full test coverage of code. But this is not what we can provide with the Java tooling, because the Java platform itself is not certified for such environments.
So you need a certified tool for that. And
a very restricted runtime environment. So all the dynamic like memory allocation, what we have in Java, is not allowed in these environments.
And to finish up with the coverage discussion, is there a sweet spot that we would say that additional coverage is a lot of effort with minimal benefits, say something like 80% or something? It depends on the project. Or is there a situation, another way to judge when we have enough testing other than intuition, as we discussed earlier?
Well, it depends on the nature of the tested code. So what I always recommend is to separate or you split your components in components which are well unit testable, especially your business logic, so the core value of your application, and separate this clearly from, I would say, glue code, for example, to wire to, let's say, a database connectivity or to the file system. And I always recommend to provide abstractions, for example, for file system access or database access. So you can create real unit tests for the core part of the application without having a database in the backend. And for the glue code as such, it's probably not that valuable to spend too much with unit tests and mocking on such code. So here I recommend really try to do integration tests. So make sure that the glue code and the whole application actually works with a real database. But this is a different test set then.
And test coverage more useful for exercising and looking at your unit test, the value of your unit tests, or is it also important for integration testing?
For unit tests, I think this is a primary value. For integration testing, integration tests always should be feature driven. So your software, your application has a certain set of features, and you should have a clear mapping between your integration tests and your features. So you have the proof that a particular feature has actually been tested. When you're down on unit tests, on the level of unit tests, the components you're testing is like Java classes, and typically it's pretty tough to map the single Java class to a feature to your application. So it's more about functional coverage when it comes to component testing. But still, it's a nice metric to look at. For example, you still can identify areas in your code or maybe modules which are not tested at all with your component tests. So you might identify use cases which has been missed in the test scenarios.
So you add new test scenarios in order to exercise those.
Right.
And moving down to specific methods in Java, we have often exception handling, try-catch blocks. How do you deal with that? Do you find it useful to add and test the code coverage both in the code and the part that deals with the exceptions? Or is it very difficult to do that?
That's an interesting question. First of all, it's difficult to do it. If you want to do it, you need to have proper abstractions, and you need to be able to mock, for example, the underlying system to emulate the exception. So, for example, let's say you have like a database driver, and there's a connectivity problem, whatever. Then you need to find a way to mock the database driver and actually simulate this exception. But this is actually something you really should focus on, not only in testing, also in the design, how you anticipate failure. What we've seen a lot in system is that the actual error handling is the least tested part, and that the original error, like let's say a broken database connection, is not the problem. The problem is the broken error handling in your application. Let's say you have like a web shop, whatever, and there's a spontaneous database connection drop, and one user might get an error if he, let's say, performs a certain operation. But what then typically happens that the actual error handling causes much more damage, for example, by doing endless retries and breaks down the whole system. This is what we've seen a lot in the past. So error handling is quite critical, and actually testing it, especially integration testing it, this is what I recommend.
So it's back to integration testing.
Absolutely.
Right. Let's turn our focus on tools, which are, as you said, very important for test coverage. How are exactly tools used to achieve test coverage? What are the specific steps one should take in order to utilize tools for measuring test coverage?
Okay, and maybe I tell you about the technical background,
yes.
How test coverage actually measured, and then we can see how this actually is integrated in various tools. So the trick here is the JaCoCo code coverage tool is completely based on Java bytecode. So the only input it needs is your class files. It could be in chars and vars, whatever.
Binaries.
Binaries,
yes.
the compiled
Yes,
binaries.
yes.
So we don't care about the source code at all. This bytecode is so-called instrumented. Instrumentation means that the control flow within your code, within the method, is inspected, and additional code is inserted. We call this code probes, and a probe records the fact that a certain piece of code has been executed. And from this information, we can infer the coverage of every line, every instruction, every branch. So this is a trick behind it. To do this modification, we use a hook in the JVM, which is called the Java agent. The Java agent is an extension to the JVM. You can load its startup, typically specified via the command line. And this agent allows various interaction with the JVM. And one possible interaction is to transform the binary class files before they are actually loaded in the JVM. And this is where we hook in. So the first and only point of integration to measure code coverage for an application is to specify this JaCoCo Java agent, which is basically a small command line option. And to do this, you can just do this manually in the command line, for example, if you start an application server. But all of our tools provide little utilities which provide the correct syntax for you and add it to the respective configuration. For example, if you have a Maven build and if you use Maven Surefire to run your unit tests, the JaCoCo Maven goal will prepare a specific property for the Surefire runner to add this JaCoCo agent to your build. And this is the first part. This is maybe the simple part. What JaCoCo then produces is an so-called execution data file, which is, again, a binary file where the information about execution of the probes is persisted. And in the second step, you want to create a nice report, like a HTML report, or XML report, and you want to see the total figures. And here you need another tool, which is the report generator, which takes the execution data file and the original class files and creates a report out of this. And typically, for example, for Maven, we have two tools. One tool is a tool, in case of Maven, it's called prepare agent, which adds the agent to your runtime before you start your test. And the second step is then create a report out of the data which has been gathered at runtime. And this is basically the integration you do with every tool. And for example, for the Eclipse IDE, this is completely hidden by the Eclemma plugin. So the Eclemma plugin does all the magic for you in behind. So when you launch any kind of Java program in coverage mode, the Java agent is automatically added to the command line that is fired in the background.
And is this running cumulative? So if you run multiple instances of your application, are the results collated together? How do you clear the results between runs or when you decide to have changed the code?
By default, when you start the new JVM, the agent assumes nothing is executed for sure. It has no memory about previous runs. But if you specify the same execution data file for multiple runs, the data will be accumulated.
So somehow your tool looks at the executed file and determines if it is the same or not, and if it is the same, it accumulates the data.
It simply appends new data to the existing file, and once you create a report, the report generator, when it reads in the execution data file, it simply adds all the data which is found in the file. So it's as simple as appending new data to the existing file.
And does the test coverage code interfere with the measurement of the metrics, or you don't care, you treat it as any other code?
No, it does not interfere with the original Java code, so it should not change the behavior of the code. This, of course, would be a bug that should be reported immediately, and I don't think we have that. But there's some interference with other tools which also use on-the-fly bytecode instrumentation, so they get into its way. Specifically for JaCoCo, the issue is that we need the class files at two places: at runtime, to actually instrument them and insert the probes, and later on at analysis time, I've read more information out of the class file. For example, the debug information, so we can infer line coverage. So we get the line coverage, or which line has been executed from the debug information. And for this purpose, it is quite critical that we see the same class file at execution time and at runtime. So imagine there's different set of methods at the file at execution time than at the file at analysis time. We cannot match the data. And here's the critical part, that some tools actually also modify the class files and change the structure of the class files. For example, add new methods to it. And then so the JaCoCo runtime sees a different class file than the JaCoCo report generator. And this causes actually problems. And
could reflection also be a problem, or is it transparently handled?
No, reflection is not a problem at all. Reflection does not change the structure of a class file. So you can access the members and the fields, but you cannot modify the structure or the behavior of a Java class definition with reflection. This is not an issue for us. But if you call a method via reflection,
yes,
it will also be shown as covered, like it would be a normal call.
You mentioned that JaCoCo is used by Maven and Eclipse. Other IDEs that support JaCoCo and environments?
Sure. So at least we know about, I think, 15 integrations in commercials and non-commercial tools. So integrations we do not on our own. There's basically integration for every IDE like NetBeans or IntelliJ. They all have integrations for that. But we are not providing this integration. The IDE vendors itself picked up JaCoCo as a tool.
And you also mentioned the SonarQube, and is it also used by other similar frameworks, environments?
I don't know exactly what closed source tools are actually using it, but I know, for example, about TeamCity or Urban Code, or also Visual Studio, Team Services. These commercial tools also provide dashboards and for their continuous integrations or continuous integration services. And they also use JaCoCo, as far as I know.
Are there other tools in this space, in the code coverage analysis for Java?
Sure. There's the other bytecode based code coverage tool. This is called Cobertura, which is also quite old, which uses basically the same principles than JaCoCo does. And then there's source code instrumentation based tool, which means the source code is modified
rather than the bytecode.
And which is clever. It was a commercial product by Atlassian, but just recently they went open source with it. It's called OpenClever now. I think you can find it on openclever.io. And this is the original source base now provided for the community, and it's still maintained by the original authors. And it's a pretty nice tool. They offer something like per test coverage, so you can have a traceability between a specific unit test and the lines touched by this unit test.
Which cannot be done through binary instrumentation.
I think it could be done.
Yes.
We are targeting large-scale products and like products with like 1 million lines of code or let's say 100,000 unit tests. And up to now, we haven't found a clever data model to have a scalable model to store per test coverage for such projects without a relevant decrease in performance. And this is probably the main benefit of JaCoCo, that there's literally no performance regression if you run JaCoCo in your build.
I was about to ask you about how does one choose a tool to use for coverage analysis and whether there are drawbacks or advantages of specific tools or approaches.
Sure, there are. So one thing is like the runtime footprint. So how much, for example, does it slow down your build or your test execution? This is one thing you should look at. The other thing is, of course, the feature set. So what features do you actually need? But there's one crucial thing. This is also the supported JDK versions. So with the new cadence of JDK releases, for the tool vendors, it's pretty tough to provide support for the latest Java runtimes. And we are pretty eager to catch up with the JDK release schedule. We are working closely together with the Open JDK project, and we just recently released support for Java 10, so just a couple of days after the official release was announced.
But it's tough to keep up with the new release. You need to adjust the instrumentation for every new JVM release.
It's very tough. The issue is that so with Java, traditionally, the specification is released with the implementation. So we don't have a time frame to adapt to the new features before we see the final release. So most likely there's not many changes at the end of or just before the release. But still, we don't have a formal specification of the new bytecode formats before we see a release. And also, for example, the JaCoCo library also needs a build stack. So we also use tools like Maven to build the library. So and here we have a chicken and egg problem. I mean, we don't have the tools yet for Java 10 available, but people expect us to release a library for Java 10.
And when you say release a library for Java 10, does this mean that it will support the new features of Java 10, or it will not run at all unless you have the new version of the library? So are the new release of JVM breaking the existing tools and the support that you have, the instrumentation for bytecodes?
You get it. So the minimum issue you have that you get a new bytecode version. The OpenJDK project decided to increment the bytecode version with every release, so there's no semantic versioning. So with every release, we need to understand the new version of bytecode. This is typically only a header information. This is the easy case because it's just about a new number we have to understand in the header. Mm-hmm. But the interesting case is when there's new functionality in the bytecode, for example, new opcodes or new structures, a new way how to invoke methods, or for example, with Java 8, we got methods, default methods, and interfaces. And these are things we need to deal with, of course, with the Java code coverage tool.
Does JaCoCo also work with other languages that create JVM?
So, of course, JaCoCo does not care about the source language. It only cares about class files. And whatever runs on the JVM, you can create code coverage for it. And it actually works pretty well with many other JVM languages, let's say like Groovy or Lombok. Well, Lombok is not our language on its own, of course, it's just a annotation framework. It also works with Kotlin, for example. We have a repository with a long list of different JVM languages with examples. The issue here is that many of these, especially high-level programming languages like Groovy, they produce a lot of synthetic methods, like they create additional methods, additional code that is created by the compiler, and you might see this code as uncovered. So the metrics you get out for these languages might not be that what you expect. So we're currently working with this, with the respective projects, for example, with Groovy, and they help us. They create annotations, class visible annotations, which mark bytecode which is generated. So we can easily exclude this bytecode from the reports.
And then you need to adapt for each language, have some an adaptation layer at the reporting level, right?
Right. So once the language like Groovy agreed on a specific annotation, unfortunately there's no standard specification for that. This is a problem. There's annotation in the Java JDK which is called generated. Unfortunately, this generated annotation has retention source code. So once it's compiled to a class file, this annotation is not visible anymore. It's not included in the class file anymore. And this is the problem why we cannot use the standard annotation. Would be nice to use it, but all the languages created their own application, their own annotation. And what we basically do, we add filters for this annotation to JaCoCo. We have this, for example, for Kotlin. We have this for Groovy. We're waiting on... we have this for Lombok, we have it for Groovy, but for example, we're still waiting on getting such an annotation or such a hint for the Kotlin language. That would be really nice. And Kotlin users are really expecting to use code coverage tools also on Kotlin.
So it seems that there's a great benefit in working with bytecode because you can cover more languages. Are there any advantages in working with source code?
In source code, so the granularity, if we map it back to source code, is just line level. So we know whether a particular line has been executed or not, or we know the bytecode instructions from that line, but we don't know about the internals of the line. So let's think about Boolean expressions with several parts in a single line. We can hardly interfere which parts of this expression has been executed, because by default the Java compiler only emits debug information on line granularity. So if you work on source code instrumentation, you can of course instrument the line and add probes with multiple probes within a single line, for example, to know which parts of the source code of this piece of line has been executed exactly. So this is one of the benefits if you do source instrumentation. But on the other hand, the drawback is that the integration in your tool stack is way harder, because you have to cut in before you actually compile your source code. You have to create a copy of your source code, instrument it, and then compile it. So you get artifacts for the purpose of code coverage only. With the Eclemma approach, especially with the on-the-fly instrumentation, you can add code coverage very late in your build chain. You can even attach an agent to an existing productive system and measure code coverage on the productive systems, which some people do.
As a Java champion, did you ever ask for specific directions in the JDK development in order to improve the code coverage analysis? Or is everything you wanted has always been there?
No, so actually there's some, JDK comes with its own or internally used code coverage tool, which is JaCoCo, and there's some interesting experiments they're doing. For example, they have an option in the compiler to create additional annotations with source code mapping within the line. So this is something we could facilitate in JaCoCo in future if we get this as a default for the Java compilers. What we actually do, we work very close with the OpenJDK project, especially if they break some of our functionality. This sometimes happens. We have a nice integration test suite, which means we compile different pieces of source code, run a unit test on it, and see whether we get the expected coverage. And this test suite, which is quite big in the meantime, revealed quite a few bugs in new JDK releases, and we work very closely with the OpenJDK project to report these issues, and they take our reports quite very serious, and we get very quick turnarounds and feedback on these issues. I think in the meantime, we're one of the top external bug contributors of the OpenJDK project.
Let me get this straight. What is the process in which you uncover those bugs?
It's an integration test suite, which involves two parts of the JDK, the compiler, and of course the Java runtime. And from our perspective, we want to see whether the code coverage tool JaCoCo actually produces the expected results from the perspective of code coverage. But implicitly, we're testing the compiler and the Java runtime. So for example, we uncovered errors in the line mapping tables. So the mapping from the bytecode back to the source code. Sometimes if they do optimizations in the compiler, this mapping is broken. And this is what we immediately uncover with our test suite, because the expected results is not what we defined in our test setup. And so we quickly identify such problems, for example, in the Java compiler. The other thing is that we have a lot of tests for, I would say, corner cases of the Java specification, of the Java bytecode specification. And we, for example, sometimes see crashes of the Java runtime with certain corner cases in the bytecode structure. And this is also what we constantly report.
Amazing. When developers see the report, in what form is the report produced? Is it integrated with the IDE? Does the IDE highlight code sections that are not covered?
This is a typical integration for the IDE. So I can speak here for the Eclipse integration. So here you get trees with an overview. You can drill down from project to package level down to class level, but you also get highlighting directly in the editor. So you see like a colored highlighting of the covered or missed lines within your text editor. It's not a separate view, it's the same text editor. You can just keep editing in the same editor. In the same editor, you see annotations for branches. You get tooltips about the branch coverage status. You can also integrate it in your standard views, like your Project Explorer, whatever, and you get annotations there with the coverage. You can configure that within your IDE wherever you want to see the code coverage. You can open property dialogues on every Java element and see overview of code coverage of that element. So Eclipse offers a nice set of extension points to hook into the IDE and present the information right there, right where the user expects it.
I presume you want to see it also at the whole project or in a class or a specific method and then drill down to code, right?
Yeah, this is exactly how it works in the IDE. For the tools for a report, the report works very similar. As for example, the HTML report, you get an tree of your project structure down to package, down to classes, down to method. And this is like a tabular view, and then you can jump right into source code and you again see the highlighted source code, which pretty much looks like within the IDE. Of course, you cannot edit it, and it's a read-only report.
Right. And when you go to a continuous integration pipeline, is there a way to turn red when something happens, when the percent declines or the coverage less than a level? How do people usually do test the coverage and integrate it with a continuous integration?
So we provide tools for that. For the Maven or for the Ant integration, we have check goals where users can specify certain metrics, for example, a given percentage on line coverage or maybe an absolute number. So let's say there must be not more than 5 classes which are not covered at all. You can specify a lot of limits which are then tested during the build, and you can fail actually the build if these minimum numbers are not reached.
And you mentioned these are per class or in terms of line numbers, percentage. What are the most useful, or which one do you typically use in your projects?
Actually, I do not recommend to use these checks or you fail your build at all, to be honest. What you can do is you can do it as like a sanity check. So you do like, okay, we in the project we have let's say 80% code coverage or 90% code coverage. Then I would do a check of, let's say, 50 or 60%, so way below than the current coverage. So you have like a sanity check to make sure that the tests are actually executed and the code coverage has been implemented properly. Because sometimes this can break. So you have like a green build, but it's just because your tests have not been executed at all. So you have some confidence that most of your tests has actually been executed. But if you really want to monitor the code coverage, I don't recommend to set limits which are like really just below the current status. For this, I really recommend using a tool like SonarQube to keep track of your coverage over time.
How is that different from integrating it into the continuous integration pipeline?
You can integrate it. For example, the Jenkins plugin for JaCoCo also gives you kind of a timeline So you can actually use both. But for the build itself, so for the Maven bit, for example, I wouldn't try to always update the check and always adjust the limit to the latest status of your project. And whenever you achieved, let's say, 1% more of code coverage, to adjust the limit again, this does not really add value to your project.
Whereas with SonarQube, you see overall trends and you maybe spot things that are going the right or the wrong direction.
And you can relate it to other metrics. For example, you get code coverage on new code. So SonarQube consumes a lot of inputs, for example, also the change history of your code. So SonarQube knows which is the coverage of new code in a given time frame. So if you have a huge legacy code base, you don't care about the overall code coverage because the project is just too big, but the teams are working on some small areas for new features and you want to monitor the new code, for example. This is something what continuous inspection tools give you.
Can you elaborate, please, a bit more about the continuous inspection tools and how they work with code coverage?
Continuous inspection monitors the several aspects of your code base. For example, rules, whether the coding guidelines are followed, or there's a lot of rules about typical coding errors. So with static analysis, you can recognize, for example, a resource, let's say input stream has been created, but it's not closed. These are all rules which can be identified by such continuous inspection tools. And they give you an overall overview of the quality of your project. And code coverage is just a piece or just an aspect of the overall quality of your project.
You mentioned that JaCoCo itself is using JaCoCo to measure its coverage.
From the very beginning. So this was when I created JaCoCo as a prototype. From the beginning, I was thinking about releasing it as an open source project. But my personal milestone was I will release it as soon as I can create coverage for JaCoCo itself, then the tool can be released. And this was actually the case from the very first release, which was 0.1.0 somewhere back in 2009.
And at what level was the coverage? Or is it now?
It's still somewhere around 95 or 98%. So JaCoCo is fully test-driven. The number of use cases and the complexity of the integration is simply in a scale that for the small team, it would be completely impossible to do manual testing on this tool. So we heavily rely on the unit tests and integration tests we have for JaCoCo. And whatever we do, let's say bug fixes, let's say new features, is always test first. So we always think about the test strategy, and we think about how to prove that the functionality actually works, and this is the only way how we add features. And this is very tough for our contributors because sometimes we get contributions without any tests, and we cannot accept such contributions. It will simply add too much technical debt to our project if we have features which we cannot prove that they're working.
These are very wise words. Do you happen to know the coverage analysis of OpenJDK? Is it measured? Would it make sense to measure it?
As far as I know, they do. They have their own tool called JaCoCo, and they measure. They keep an eye on code coverage, as far as I know. But the tool, I have never used the tool. I think it's pretty tough to use it outside the OpenJDK project, so I cannot judge about the tool or how it's actually used by the OpenJDK project. I'm not very familiar with their build pipeline and their continuous integration pipeline. OpenJDK is not that open as the name might suggest.
Yes, always the build structure and how the project internally builds and what it requires can often be a difficult part for a project to accept contribution and be truly open. Do you happen to know other figures from other projects, so coverage figures, so that our listeners can get a feeling of where they should aim at?
So what we typically see is a project which really does test-driven development, they always end up beyond 80 or 90% test coverage if they have the right process to think about testing first, create the test first, and then actually write the code.
And do you happen to remember the interesting bugs you have uncovered by increasing test coverage? Something that's particularly stayed in your mind?
It's not right now. It's as I said before, like if you want to increase the test coverage after the fact, you lose a lot of benefits, like creating correct code from the beginning or creating proper APIs. This is all benefits if you practice test first. So adding code coverage after the fact to a project is always tough, especially if the structure of the project does not allow. So if the project does not actually have real components, if it's like just one huge block of interconnected components and you cannot isolate single parts to test those parts. So testing or adding coverage after the fact is something I really don't recommend, and which is like really tough and typically goes along with refactoring the original code base to have actually testable components.
And of course, the project will not have testable components because it was not implemented in a way that would together with unit tests. So it's
right.
The two things go together. Are there any drawbacks associated with tracking code coverage? You mentioned about gaming the metrics. Other things people should look out for?
No, it's basically about setting up wrong expectations and just looking for code coverage metrics. Also, what I have seen, which I consider very dangerous because you lose all the benefits of test first, that unit tests are created by separate teams. Like you have like an offshore team, and the offshore team is just responsible to add unit tests to some code base. And this is not the way how you do it. So this will not add any quality to your original code.
It sounds really misguided, but I can really imagine companies doing it. Yes.
But this is a fact. This is a matter of fact, and I know projects which work exactly like this, and I would really not do it this way. Not at all.
Dilbert comes out of real life. It's not some imaginary scenarios. So what should I tell my managers to persuade them to adopt test coverage analysis?
Don't tell them at all. Just do it. Just do it for your team. Mm-hmm. Just have a working agreement within your team that you do test first, but don't make it an official metric. So this is what I always tell in my talk. So don't tell your managers about code coverage. Just do it and keep an eye of it.
They will track it and they will make it a trackable metric, and then it will lose value because people will manipulate it.
Absolutely. This is what will happen. If it's a management metrics, then it's an easy metrics. Yeah, just a number, and it's easy to understand for management, but it will not add value if there's no proper process behind that.
Mm-hmm. Mm-hmm. Mark, is there anything else I should have asked you but didn't? Something you would like to share with our listeners?
Maybe about new Java versions and challenges with the new Java versions.
Mm-hmm. So what are the challenges of new Java versions?
The issue you have with the latest Java versions, or maybe even starting with Java 7 and Java 8, is that we do code coverage on Java bytecode. And the early Java versions, like say till Java 5 or Java 6, there was a one-to-one relationship between source code and bytecode. So we could easily map back the bytecode to the source code. With new versions, we see new syntactical sugars, something like lambda or something like try with resources. And for this, the mapping is not that simple anymore. But because what the OpenJDK project decided is to put more functionality into the compiler. So things like try with resources ends up in a complex nested structure of try finally blocks in the class file. And the issue we have with the code coverage tool to map back or to recognize these structures in the class files and map it back to the source code during the reporting time. And this is getting more and more tricky with the Java language and the new features of the Java language.
Mm-hmm. Is bytecode is just-in-time compilation creating any additional problems?
No, we're working on bytecode level, and just-in-time compilation goes down to the machine code. So just-in-time compilations kicks in after we instrumented the bytecode. This is for the structure, but what we actually see if you have a library which does like real number crunching, we can see some performance digressions here because due to the additional probes, for example, inlining is disabled because the method is growing. So if you have like a simple set on getter, which is typically inlined by the just-in-time compiler, after instrumentation with JaCoCo, the method on bytecode level grow too big to be inline. So this is the only point where we interfere with just-in-time compilers, that due to the increased size of the methods, we see some performance drops, especially at hotspots where there's a lot of execution on small and tiny methods.
Marc, thank you very much for being with us. Where can listeners find out more about the topics we discussed?
Of course, on the JaCoCo.org website. So there's complete documentation. This is one thing we try to do. So it's not just test first, we also do documentation first. So whatever we add and features, the documentation will be updated, and we try to provide a consistent view on the tool from the documentation and the functionality point of view. Also on the website, you will find a long list of conference talks and presentation we have done, especially also Evgeny Mandrikov, who is the main contributor to the project. There's a lot of funny and interesting presentations about how to use it, and also about implementation details, so you can learn about how it is implemented and what are the tricky parts with the new JaDK versions, for example.
Oh, sorry. Excellent. Thank you again.
Okay, thank you. Thank you for having me here today.
This is Diomidis Spinellis for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.